All right, in this video, we're going to look at circuits worksheet number 17, 18, and 19. We're all looking at this circuit here. This says, what is the equivalent resistance in the combination circuit? So by equivalent, it just means what is, if I replaced all this with one resistor, what resistance would I get? So if we look, we have these three in parallel, we have to add together, and we're going to add that group to this one in series. So first, let's add these three in parallel. So my total resistance of these three is going to be, the 20 to the negative 1, plus 10 to the negative 1, plus 10 to the negative 1, all to the negative 1. So just each resistor, added them together as their reciprocals. Okay, do that. So if we put that in our calculator, we just have 20 to the negative 1, plus 10 to the negative 1, plus 10 to the negative 1, all to the negative 1. And we end up with 4. Okay, so now if we redrew this, it's basically like we have this circuit that is this little 12-volt battery. It comes out to this 2 ohm resistor, and we've replaced those three with this 4 ohm resistor. So really that circuit and this circuit will act the same as far as the battery is concerned. So now if we want to add up to get the total resistance, so this should probably be the equivalent resistance instead of total. So it's the equivalent of those three, and then the total of the circuit is just going to be in series. We just add them together, 2 plus 4, and we get 6 ohms. Okay, so our answer for number 17 is just going to be 6 ohms. Now in 18 it says how much current is in one of the 10 ohm resistors in the diagram shown above. So we're looking up here and we're looking at current. Well, as that current flows around that thing, it's going to go through here, but now it's going to split among these three. How are we going to figure out how it's going to split among those three? Well, if we had the voltage on all those things, we have voltage and resistance, we could find current. So let's see if we can find voltage on that area. We know through a series circuit, the current that comes out of the battery, this total current, and then this current through the 2 ohm resistor and the current through this 4 ohm resistor are all equal. I total is the same as I2 equals the same as I4. Okay, all the currents are the same. So let's just find what those currents are. We know the total resistance, we know the total voltage. So on 18, if we take this, we can find that the total current is just the total voltage divided by the total resistance, which is 12 volts over 6 ohms that we just found, and we get 2 amps. So we know there's 2 amps flowing everywhere. Well, let's find the voltage at this spot here. So the voltage at the 4 ohm, this is the parallel part, right? This is this part up here. That voltage is going to be that current, which we just said was 2 amps everywhere, times that resistance, which we just said was 4 ohms. And we get 8 volts. That means there's 8 volts in different colors so we don't get quite so crazy here. 8 volts drops right here. Well, that 8 volts is the same as there. I have this spot. So if I redraw this, this was my 20, my 10, and my 10. We said there's 8 volts from there to there. If there's 8 volts on that resistor, he's basically in parallel with these. He just replaced these. Oh, sorry, I forget to hide this little doodad. It even says hide. Now you can see things better. So I know I have 8 volts across that whole section. Well, what does that do for me? Well, it said, what is the current in the 10 ohm resistor? Well, if I have voltage and resistance, I can find current. Current through the 10 is just equal to the voltage across the 10 times the resistance at the 10. Well, the resistance, of course, is 10 because it's a 10 ohm resistor. The voltage on all of them is 8. So when I do that, I get 0.8 amps. And now I have my answer to number 18. Okay, so that's the number of the problem. Now the last one says, what is the voltage on the 2 ohm resistor? We have 2 ohm resistor here. So number 19, what's that voltage? The voltage on the 2 ohm resistor is just going to be the current at the 2 times resistance at the 2. Well, we know the resistance at the 2 ohm resistor is 2 ohms because that's what we just put in the title here. Okay? We just said back here that the current going through the 2 ohm resistor was 2 amps. So 2 times 2 is 4 volts. Perfect. What did we say we had back here across this section? We said we had 8 volts. Remember, for a circuit that's series, total voltage is voltage 1 plus voltage 2. Well, there's voltage 1, there's voltage 2. 8 plus 4, doesn't that equal 12 that we started with? So it all worked out. All right, and that's 17, 18, and 19.